Thank you, Martin. And hello, everyone. Good morning or good evening from where I am in Sydney, Australia. It's just after 9 p.m. at night. So just making sure everyone can hear me and you can see my screen okay. Yes, I can't see anything right now, but I'm going to presume that's an okay. All right. So I just want to extend a very warm thank you, first of all, to Martin for the kind invitation to be part of this webinar. And as Martin said, I've had the privilege to work with him and also jury and a number of other local and international subject specialists around recreating ancient Egyptian limestone stelae. So in my talk today, I'll begin by providing some background to this work. In particular, for those of you listening in who may not be so familiar, I'll start with just what are ancient Egyptian stelae and also how this research project has come about, before sharing with you two case studies of our experimental work that we've undertaken together over the past several years. The first of these is to recreate parts of a first intermediate period false door in the Fitzwilliam Museum in Cambridge, which we did in December 2021. And the second is recreating parts of an early 18th dynasty stela, where I now work at the Chau Museum at the University of Sydney, which we did in May last year. I'll then share with you two key outputs of this work and how we are reaching diverse audiences with it, including through a pop-up museum where we're engaging with communities who might not otherwise come to our museum or have the opportunity to access our research, and also an edited book that we are currently working on, which we hope will be available in the first part of next year. So what are ancient Egyptian stelae? Essentially, they are slabs of stone that have been inscribed and or decorated with painting or relief. While there are different types of stelae, such as votive and commemorative, the focus of this body of work is on funerary stelae. So these are essentially grave markers that commemorated the deceased. They provided a place for priests and family members to leave offerings, and they're essentially a magical portal. So the ka, or the life force of the deceased, could magically travel back and forth between the door or the stela to collect and consume the food and drink offerings that would sustain them for eternity. So I have a personal long-standing interest in stelae. It formed the subject of my PhD thesis, which is now published, as you can see here, specifically focusing on the first intermediate period. But while this work focused very much on more traditional approaches to stelae by developing a series of dating criteria applied to a corpus of 677 false doors and stelae from all over Egypt to help cast new light on dating and historical aspects of the period, the research has now expanded to take on new dimensions thanks to my postdoc that I undertook at the Fitzwilliam Museum in Cambridge between 2018 to 2021. So just in short, this postdoc was very much focused on coffins, and you'll see the connection in just a moment. And we applied advanced imaging techniques such as CT scanning and X radiography. So pictured here is Julie Dawson, the former head of conservation at the Fitzwilliam Museum, and the late Jenny Marchant, a conservator who worked at the Fitzwilliam for a long time, CT scanning the coffin lid of a third intermediate coffin of Nespli Shefit. But by applying these advanced imaging techniques and then working with different subject specialists, like an expert in historical painting techniques, an expert in ancient Egyptian carpentry, a pigment specialist, a radiologist, a geologist, conservator, and so forth, we were really able to build up a much clearer and holistic understanding about the coffin industry, so how coffins were made and how they were decorated. And it revealed some very interesting insights. Among these, from the CT scans and the X-rays, is how many pieces and planks of wood went into making a coffin, what types of joints were used as well. Excuse me. And we also did some experimental work, so recreating the coffin carcass itself made out of the wood, and then seeing how the surface preparation layers were applied, and then how the pigments were also applied one by one to the final varnishing. So this research brought about some really incredibly important new findings. One of the most notable being that coffin reuse, including the breaking up of older coffins to make new ones, was much more prevalent in ancient Egypt than previously thought. And then it also then brought about a whole range of other new questions that I've now been applying to stelae. For example, when is it okay to reuse someone else's coffin to make your own? did a specific amount of time have to pass before this practice of coffin reuse is made acceptable? And do we really understand the ancient Egyptians' concept of ownership and eternity? And also during other intermediate periods. So in ancient Egyptian history, we have these high points, these kingdoms, when it's a time of centralization and prosperity, and then abutted by intermediate periods, which are typically characterized by decentralization. There might be rule from provincial rulers or from external people. And often in the literature, times of scarcity is associated with the intermediate periods. But how true really is this? So I effectively applied all these questions to the subject of stelae to develop a new strand of the project, focusing initially on this first intermediate period false door in the Fitzwilliam Museum's collection. It belongs to a woman named Hemi-Ra, and it's suggested to come from a site called Busiris in the Delta, in the north of the country. Now, my colleagues and I have already presented and published on this door quite extensively elsewhere, so I'll keep my description brief. But the key thing that I want to point out to you of relevance in this paper is that several sections of the door have been smoothed over, modified, and or recarved. Specifically in these areas marked in green. So the central panel is the area here in the top center, the rectangle, and also in the faces and some of the upper bodies of the figures at the bottom of the jambs, including the entire figure on the far left side of the proper right outer jamb, and also the faces of the seated figures. Now, interestingly, these areas, as you'll see on this line drawing, are also devoid of any pigment, as the microscopic examination and visible induced light luminescent revealed that the whole false door is most probably once originally painted with red ochre and the hieroglyphic text overlaid in Egyptian blue. Now, if you look at the modified and recarved areas more closely, starting with the central panel, you'll see that the stone appears to have been smoothed in a number of places, including underneath the offering table, in front of Hemi-Ra's body and face, around the back of her head, and behind her upper body down to where she is sitting and underneath her chair. The figure's wig also shows signs of having been modified, accentuating the contours of a smaller head, which may have originally been carved in the same position, possibly belonging to an earlier owner of the door. This is further reinforced by what appears to be a second profile along the outer contours of her face. But the fact that the whole central panel appears to be set back quite deeply compared to what we'd normally see, with the profile of the stone sloping in keeping with the downward motion of a chisel, would suggest that this carving took place when the door was upright, so standing vertically, quite possibly when it was already in the tomb or at some point after that. The fact we can also see some red paint trapped along the edge of one of the apertures, and also in here, perhaps suggests that it was once completely painted red as well, and what we may be seeing instead is evidence of the whole central panel having been recarved. But the question is why? If we now look at the figures on the bottom of the jambs in these areas marked in red, distinct variations can also be observed in the patina or surface texture of the stone itself. The stone appears much whiter. The carving is also deeper, but with much attention, albeit crudely given, to the figure's large almond-shaped eyes, nose, mouth, and in particular, the large full frontal breasts. In fact, these nuances in the decoration would suggest that these figures have been recut and that the changed whiteness and brightness of the stone is to be explained by the recutting, so removing the weathered and darkened material to reveal the fresh, paler rock beneath. Now, something to also take note of with the figures at the bottom of the jambs is the way in which they have been represented, which in fact suggests that the owner of the false door was perhaps not originally intended to be female. For example, you'll see there are clenched fists, which appears with most of the figures, and this is an attribute usually only ever associated with males. Two also hold a length of cloth. The feet, in all instances, are also spaced apart, as opposed to the joining or overlapping depictions found with females. While the wigs appear to have been originally carved short and close to the head, but in some cases have been reworked and extended below shoulder level. The ponytails and the seated figures may well have also been a later addition. Now, since American Egyptologist Henry Fisher first published on this false door more than 40 years ago, scholars interpreted what we are seeing in these different figures as Hemi-Ra being shown at 3 different life stages. The first stage, as a naked youth or girl on the bottom of the inner jambs. The second is as a woman in her prime, note the language. And the third is as an older woman with frontal sagging breasts. Now, no one picked up on the evidence for the modifications and recarving. Thus, what it seems we're actually seeing are 2 different phases of ownership and modifications made to this door. So in short, in the first instance, it was seen that the false door was originally made for a man, but it was left unfinished. I think that only the figures at the bottom of the jambs had been carved, and possibly also part of the central panel, before it was acquired by Hemi-Ra and adapted for her own means. Since we do not see any modifications made to the hieroglyphic text, this was done afterwards. So I don't think the door was ever intended to show Hemi-Ra at 3 different life stages, but rather it was consequential because of the state of the door once assumed for Hemi-Ra. Thus, to make it more feminine, the artist and carver added long-stemmed lotus flowers, he extended the wigs and added the ponytails, etc., but was still somewhat sloppy about this, hence some of the remaining masculine qualities that we see. As for the recarved areas, including the faces and the frontal drooping breasts, I think these are to be explained by a second phase of modifications, which brings me to point 2. Mainly based on the evidence around the absence of red pigment in these recarved areas, including on the central panel, plus the freshness of the stone underneath, I think that these modifications were made in the late 19th to early 20th century, obviously before the door was sold to the Fitzwilliam Museum in 1909, to help enhance the false door's appeal and saleability on the antiquities market. And this explanation would make sense based on the acquisition history via a man named Michel Cassira. He was known for dealing in fakes and forgeries, and also the fact that the door would have been considerably faded by this time, which means that the modern carver was never aware of the need to repaint these areas in red. So, based on this object's fascinating
Hello, apologies. We will try to reconnect with Melanie and continue with the talk.
Okay, hi everyone. Martin?
I can see you, yeah.
So when did I drop out then? I'm going to turn my video off.
When you switch to the slide where we were in Cambridge doing the experiments.
Okay, so not too far ago. That's encouraging to hear. Just bear with me 1 second.
Yeah, this one.
All right, so play from current slide. Okay, I'll just restart this whole slide and then I'll move on from there.
Thank you.
And apologies for that. So based on this object's fascinating and complex life history, we embarked on our experiment to try and understand better the process of carving and recarving the door. In particular, fashioning the false door form, carving the various architectural elements, inscriptions, and iconographic motifs, and the order in which the various elements were carved and so on. We also wanted to see what else could be learned about how the false door was modified, adapted, and or reused. More specifically, under what circumstances and conditions were these modifications and recarvings done? How much care and precision was involved? How much integrity for the original object was maintained, and so on. Although not all of these questions have or can be fully answered, it has certainly put us on a new, fascinating and incredibly enlightening research path. The experiment began with trying to source the most closely comparable limestone to Hemi-Ras-Fal-Store, which had been identified as Tura limestone by geologist Trevor Emmett. More specifically, sample 237 from the Rosemary and Dietrich Clem collection, as pictured here in the basement of the British Museum, where the incredible archive of Rosemary and Dietrich Clem's geology collection is kept. But, of course, Tura limestone is not so easy to source in the UK. It's even harder in Australia. So I made a visit to Cairo the week before our experiment to pick up some actual Tura limestone, although I was only physically able to carry back one of these blocks with me. And I'd just like to acknowledge Noor Mohammed Badra for his help in sourcing these blocks for me, and also a very kind colleague in Kent, Mick Oakey. I'm not sure if you're listening now, Mick, but he was very kind to also post us a sample from his own collection to use. And we also worked with colleagues to make craft replica tools. So Dr. Geoffrey Killen, a specialist in ancient Egyptian carpentry, made a bow drill used for drilling small holes, and also a mallet for striking chisels, and a copper-bladed push saw. And while the bow drill and other tools that Jeff made are typically used for woodworking, we were surprised to see just how well they worked on the relatively soft Tura limestone, which you'll see shortly. While Jiří Komošek, based upon the research of Martin, produced a set of low tin bronze chisels, mimicking the arsenical copper that Martin and Jiří's researchers found to be the main metal composition of tools from the whole era before the New Kingdom, including the First Intermediate period. And the use of low tin bronze is justified on the basis of the study by Heather Lechman, which compares the properties of both alloys. Now, this particular set was recreated from the forms of surviving examples from the late 6th dynasty copper tool blades found in Giza tomb G2381, shaft Z, and are chronologically close to the production of the false door in question. The replica tool blades were made of an alloy consisting of 4.5% tin and 95.5% copper. Now, we undertook the experiment over 3 days, so the 8th, 9th and 10th of December in 2021, in the Antiquities workshop at the Fitzwilliam Museum in Cambridge. This, of course, meant that we were working indoors, using artificial light during winter, rather than the natural, warmer outdoor conditions that the door presumably would have been carved in ancient Egypt. Another complication were the restrictions during COVID, which we often forget about now. So the first part of the experiment really just focused on getting to know the materials and the capabilities of the tools on the different limestone surfaces. So after splitting one of the limestone blocks into 3 sections to give us more surface area to work with, stone carver Andy Tanser focused on experimenting with 3 different smoothing techniques. Now, I have quite a number of embedded videos in this presentation, which I'll share with you, and this is partly the reason why my computer is struggling a little bit right now. And just to give you the heads up, there are some unpleasant squeaky sounds, in case you're a bit sensitive, in the next presentation here. Okay, so the first of these was using the side of the chisel, which, as you can see, generated a lot of fine limestone powder, which would have presumably been saved and reused to make mortar. Well documented. We then tried a block of coarse grit stone with water. And then finally, a length of tamarisk wood used as an abrasive. Different abrasives were tried, including rutile, an oxide mineral composed of titanium dioxide, but this is too fine. Aluminium oxide, which smoothed the surface quite well, and ground emery, which also achieved a smoothed effect. However, none of these were as effective as the side of the chisel. This technique also caused a slightly undulating effect, which we can also see on Hemi-Ras-Fal-Store. But you don't get this effect from a rubbing abrasive block, which leaves the surface much flatter. We then turned our attention to some of the hieroglyphic text. I have another video to share. Now, Andy carved 3 signs in the writing of Osiris, the seer, onto the section of Tura limestone, which had been smoothed with the scraper. And as you can see, it's quite delicate work. This took about 1 hour to carve, and using the bronze chisels, Andy was able to achieve beautiful, sharp, crisp edges. However, he had to constantly flip the bronze chisel over, rather than stopping and sharpening on a whetstone, since a little burr kept developing on the tip. Traces of the tin bronze also kept coming off onto the surface, leaving a greyish colour. It's therefore interesting to note that under microscopic examination, we were unable to detect any surviving traces of metal in any of the carved areas on Hemi-Ra's door. From this process, Andy also observed that it was almost certain that a different person cut the hieroglyphs from the person who masoned the stone to shape, based on the different levels of skill and accuracy involved. This is reflected to some extent in the later working practices of the workers who created the tombs in the Valley of the Kings. Now, the process for carving the hieroglyphic signs also started with a shallow outline of the sign being cut first before the angle was deepened. This acted as a firewall to prevent the stone edge breaking outside the desired area. But inevitably, it also created a raised area in the centre, which had to be refined, most probably by scraping. Now, interestingly, in almost every sign on Hemi-Ra's door, the raised centre has been smoothed out, and there are no signs of these chatter marks, which you can see in this picture on the right here, which is the natural effect caused by the chiselling of stone. This is a clear sign of the care and attention to detail paid to Hemi-Ra's false door. Now, after carving each sign, Andy had to resharpen his tools.
No, I mean, this isn't great in terms
So
of
here you can
speed.
see him doing this on a whetstone, but the point very quickly became hardened and brittle, which just goes to show how many sets of tools the ancient Egyptians would have probably needed to have had on hand. Presumably, they would have also had apprentices working with them to do the resharpening and to hand over the replacement tools. And here you can see 2 line drawings from the causeway of King Unas at Saqqara and also the tomb of Pepiunk the Black for a Mare, showing the sharpening of tools. Now, to demonstrate the breakouts that I mentioned earlier, Andy demonstrated how either over-carving or having a lapse in concentration can cause an edge to blow out by too much force, or trying to work too quickly. Now, impressively, there are very few examples of blowouts occurring anywhere on Hemi-Ra's false door. There is one possible example here in the writing of Is, tomb on the right, but to repair a blowout like this, you need to either cover it up with pigment or plaster, or carve everything back and then recarve it again, which is a mammoth amount of work. The very fact that there are so few blowouts of the edges on Hemi-Ra's door is further evidence that the carver or carvers of this door had a sound knowledge and understanding of the stone and their tools. In other words, they were quite experienced. Now, on the second day, Andy carved the head from the central panel onto the 3rd Tura limestone panel. And it was really interesting to observe Andy's posture and the physical arrangement as he was working. His shoulders rolled forward, alternating between sitting and standing, the constant manipulation of his tools from one hand to the other, and then to both, always rotating around to get the best effect without blowing out the edges. In Andy's words, it's all about finding the optimum angle of the chisel and finding the cutting point. And of course, this is clearly reflected in the tomb scene decoration, as you can see here in Replica's tomb from the 18th dynasty. Now, being part of this experiment was also very multi-sensory, and it's important to point out the rhythmic sounds of the chiseling.
There are various techniques for chiseling when you're masoning. You can leave the chisel on as I'm doing, and then have a quick look, just to check you're going too steep on that. Or the other technique is to look close.
So you have these rhythmic sounds, and there's the smell of the powdered limestone, which is a familiar smell in and around various parts of Egypt still today. We also have to remember that there were many carvers in the workshop simultaneously. So it would have been very noisy, smelly and dusty, with constant flakes of limestone ricocheting about the workshop. And of course, they didn't wear any protective eyewear or earmuffs. Now, it took Andy just under half a day, or about 3 hours to carve the head and shoulders of the central panel figure.
Yeah.
Obviously, with more experience and familiarity with the tools and stone, this would be faster. Something else you've probably also picked up on from the video footage is the chit chat that goes on, in this case between Andy and us. This also gives you a sense of what it would have been like in an ancient Egyptian workshop. Chit chat, the pounding of tools, the ricocheting of limestone chips, the sweet smell of limestone powder, and plenty of limestone dust.
We did some work in Norwich for the theatre house.
The other component of this, of course, is the physical wear and tear exerted on the body. Repeated inhalation of limestone dust, for example, can cause scarring of the lungs, silicosis, which can be fatal. Then there are the other side effects: bad backs, calluses, eczema from the stone dust, constant cuts and abrasions, which can lead to risk of infection, joint degeneration, general crushing injuries, and nipping of fingers and toes caused by handling heavy blocks of stone. And in the case of working outside, the effects of glare working on light stones in the full sun, as well as possibly even sunburn. Returning to the carving of the figure on the central panel, Andy struggled to recreate the very fine carving of the locks of hair in the wig. Using the chisel, he needed to keep sharpening and refining the point, finding it much easier in the end to get the required sharpness with his modern tungsten chisel. He also tried using flint, but as it hadn't been shaped, it similarly proved to be too thick and cumbersome to use.
It's going really well. I think there's getting very close to what Andy can achieve with these tools.
The next part of the experiment focused on trying to fashion the various elements of the false door, in particular the outer jamb and the decorative torus moulding. However, we did have to make some special allowances with this, using a slab of Portland limestone, since it was the only large slab of limestone approximating to Tura that we had to hand. And because we were limited by time and budget, Andy did have to use an angle grinder to shape the preliminary form for speed. And a much softer copper alloy chisel was made by Jeff to fashion the jambs, as this particular chisel allowed Andy to achieve a much sharper point. Now, the actual carving of the decoration of the torus moulding was very easy to do, providing that the setting out had been properly done. This whole process was estimated to have taken around 4 to 5 hours and followed a similar process to carving the hieroglyphs, cutting it at a shallow angle to create the outlines and then deepening as required.
Just finish here, then I'll work.
We then proceeded with some further experimentation, in this case using Jeff's replica saw to try and cut through the Tura limestone. As you can see, this worked very well. As with ancient hand saws, the pitch or the distance between each tooth varied and were irregular in shape, and the set was created by pushing each tooth to one side of the blade, unlike the set on a modern saw, where each saw tooth is pushed alternatively to the right and left of the blade. So some summary thoughts. Tura limestone is a superb stone to work. It's relatively soft and very fine grained. It's robust for building structures. It holds a sharp edge. It's consistent and it has few inclusions, making it an ideal stone to work with. The Egyptians understood the properties of the stone they were working, and Tura limestone was clearly selected for effect. Tools used in wood carpentry can also be perfectly modified for stone. Hemira's false door was carved by skilled craftsmen. There are few blown edges, the centres have been smoothed out, and there is demonstrated precision. So what does this say about first intermediate period art, which is typically passed off as being inferior or subordinate? It seems, historically speaking, that too much emphasis has been placed on style over workmanship. But as this presentation would suggest, this would seem unfair. Hemira's false door demonstrates exquisite workmanship, care and attention, but certainly was not carved in a hasty or crude fashion. So at this point, I left Cambridge to take up a new position at the Chau Museum, pictured in the top left here at the University of Sydney in Australia. But of course wanted to continue this work, so adapted and expanded the project to focus on the Nicholson's collection of 20 ancient Egyptian stelae dated between the late Second Intermediate period to the Ptolemaic period, some of which are pictured here. So all of these date after the time of Hemi-Ra. Now, in this expanded project, the traditional approaches of studying the text and iconography have been combined alongside the technical analyses and expertise offered by different subject specialists in order to identify the type of stone used and where it may have been quarried from, the different types of tools used to carve the stelae, and to understand better how the tools were used and the possible order and orientation in which the carving may have taken place. Another component is identifying the pigments used. And finally, looking for evidence of modifications, including defacement and reuse. Now, this expanded project was initially made possible by a postdoctoral fellowship that I was awarded by Macquarie University's Centre of Ancient Cultures Research in the Environment, or CAISH. And thus, owing to the parameters of this, the project initially focused on the discrete group of 8 New Kingdom stelae in the museum's collection before being expanded to include everything else. Now, as with the Hemi-Ra project, we have examined the lithology and geochemistry of the stone and undertaken XRF and reflective qualitative color analysis of the stelae. This work was undertaken by Professor Damien Gore, pictured here, of Macquarie University in Sydney, and then compared to measurements made on selected samples of limestones of known provenance, so 44 samples from 9 known locations with supporting XRF analyses by Trevor Emmett, who also worked with us on the Hemi-Ra door. Again, consulting the Rosemary and Dietrich Clem archives of the British Museum with the aim of determining the source quarry of the limestones. But I should just point out that these measurements had already been taken by the Clems. No new analyses were able to be taken for this work. Not that we did try though. So the limestone stela selected for our second experiment is this one here, NMR.53. It belongs to a man named Ahmose and probably comes from Thebes. It's a fairly typical example of funerary stelae from the early New Kingdom period, with its round-shaped top and composition arranged into 3 distinct registers, with the Shen sign flanked by a pair of Wadjet eyes at the top, the offering scene in the middle, and a horizontal rows of hieroglyphic text at the bottom. The stela's surface is well smoothed, and the scenes and text, all decorated with polychromy, are carved in shallow incised relief. This particular stela was donated to the museum by Sir Charles Nicholson, the founder of our museum, in 1860, although they were actually acquired by him during his travels to Egypt several years earlier in 1856 to 1857. Now, based on the work undertaken by Damien and Trevor, the source of limestone for this stela is most probably from the Gebel Tugh quarries in Upper Egypt, so just north of Abydos. Limestone sourced from Gebel Tugh in the south are considered comparable to limestone sourced from the Tura Masara area near Cairo, modern-day Cairo, given their fine-grained and uniform appearance. They are also said to be one of the better quality limestones available to the ancient Egyptians. For our experiment, we thus also sourced some blocks of Tura limestone from Cairo, and I just want to thank this time Eve Murta, who kindly assisted with bringing these to Sydney for us last year. Now, in terms of the tools, we worked closely with Martin and Jury to identify a number of tools from different New Kingdom contexts, which we believed matched up with those used to carve this stela, and also other New Kingdom examples in our collection. So being led by the generally small size of the stelae, Ahmose's measures 44 centimetres in height by 29 centimetres wide, and also the fine relief work, which indicates that much smaller tools that have been used to execute the carving, in contrast to Hemi-Ra, several late Middle Kingdom to New Kingdom settlement sites were identified with suitable finds of chisels. The first of these, the workshop structures excavated at the Ramesside capital of Paramses, or Cantia. Among these include a range of chisels and punches made presumably of tin bronze, such as these ones on the left here, which were excavated by the Palazius Museum in Hildesheim. The other two chisels on the right, also of New Kingdom date, come from the Austrian Archaeological Institute's excavations in Tel el Daba. From this site, chisel 6110 was chosen. Originally made of arsenical copper, the chisel is thin, but with a flattened side opposite the blade, and dates to the later Middle Kingdom. The other chisel, 4207, is comparatively sturdier and heavier and dates slightly later to the Second Intermediate period. Based on the size of these chisels, therefore, we are talking about using something like a very small stone pounder, as you can see in the top right here, rather than a mallet, which is used for much larger chisels in masonry, for driving the chisel, or possibly even flint. It's also unclear which of these smaller chisels originally had a wooden handle and which did not, another research question for our project. Now, in terms of larger chisels for fashioning the overall shape of the stela, none have been found at Cantia, but examples are known from both Tel el Amarna and Tel el Daba. One of the largest chisels found at Amarna, pictured on the left here, and replicated for this experiment, is a 24-centimetre long cross-cut chisel. That is most probably a chisel that was originally half a cubit long and then shortened with use. It still represents a considerable weight of metal and must have been used in very general tasks of quarrying and masoning. The chisel was found in square 45, and in the same square was also uncovered this 7-centimetre long chisel illustrated here on the right. So based on this research, Jury produced for us a group of replica chisels, some duplicates with and without wooden handles, from a tin bronze alloy with a tin content of 6 to 10%. So that's a higher tin content than Hemi-Ra, between about 1.5 to 5.5%, which we used as part of our second experiment, which took place on the 23rd of May last year. Now, this work was undertaken in the museum's exhibitions workshop, pictured here by British-Australian stone carver Jamie Sargent. He's shown second from the left in the denim jacket, with the focus really being on trying to understand better the functionality, durability and ergonomics of the tools during a different time period, location, and on a much smaller sized stela. And I just want to share with you some of the key findings from this second experiment. So, as opposed to the false door of Hemi-Ra, in which the chisels needed constant sharpening and even replacement, the entire stela of Ahmose was most probably carved without any sharpening at all. Jamie was able to maintain a sharp edge throughout the entire experiment, which is obviously due to the smaller scale of the stela, the fineness of the incised relief, as well as the metal composition of the chisels themselves. The arsenical copper used in the chisels on Hemi-Ra's false door being much softer than the ratio of the tin bronze employed here. Another possible explanation for this is that we think these smaller chisels might have functioned a bit like a pen.
It seems natural to a lot of that, the glyphs, as you call it. You know, like where it's just a line, I can just make shapes everywhere.
Wash across these guys,
you know,
different to what you see on.
And it's there. It's even these.
And it was so much quicker, right? Do you make it like what, 10 seconds?
I'm just consistent pressure.
So in this case, no driving instrument would have been required to create a line, and thus possibly no wooden handle would have been needed either. Even though the incised relief might not appear to be of the highest quality, particularly when compared to the type of art and sculpture produced by the royal workshops at the same time, there are also very few blowouts or plucks in the stone, just as we observe with Hemi-Ra. That is, where the carver uses too much force and overcarves the lines, blowing it out, as you can see here on the right. So to see such clean lines means that the artisan was quite accomplished and was familiar with his tools and the material that he was working with. The modelling or relief on Ahmose's stela is also deeper on the left side, becoming shallower as you move to the right, suggesting that the carver worked in the opposite direction to the way the hieroglyphic text and scene is read. This most probably also indicates that the carver was right-handed, working left to right as a right-handed carver, also removes the risk of abrading the draftsman's line as you work on the figurative elements. Sorry about that line there. You can also see the start and stop line of the chisel and where the blade fans out. So clearly moving here from the left to the right direction. Now, another interesting observation is that while recreating parts of Ahmose stela, Jamie observed that the line for modelling is the same as the drafting lines. In other words, Jamie does not think the draftsman and carver were different people on this stela, but the same. The final preliminary observation to share here from this experimental work is that Ahmose stela is estimated to have taken about half a day to make, from the fashioning of the round-top stela itself to the carved scenes and inscriptions and the application of the pigments. Given that the draftsman and carver seems to be the one and the same person, it is not impossible that they may have also painted the stela too. We can only surmise about the fashioning of the object itself, which might have been pre-done and bought off the shelf or made at the request of Ahmose. Another component of this project is tracking the changes in the shape of the chisel tips before and after carving by means of silicon impressions. All replicas were moulded before the experiments took place, and the chisels used most frequently during the experimental work were moulded after several phases of use. The imprints have yet to be studied under the microscope and compared both before and after use. Now, while this research has opened up new ways of seeing and understanding ancient Egyptian stelae and created a new level of appreciation for us in terms of their workmanship and their production, it's also created for us a new lens through which we can engage different audiences in the museum context. And that is the lens of how things are made. We have thus been delivering a pop-up museum where curators and researchers bring real museum objects, craft replicas, activities, and also giveaways into the heart of communities who might not otherwise have the opportunity to visit our museum or access our research. We've popped up in hardware stores. So this is Bunnings, which is a bit like B&Q in England, a very fitting location for topics such as how Egyptian stelae were made and decorated, since people are already thinking about how to fix something, different types of materials are on their mind. So there's a very nice synergy there. We've also been popping up in shopping centres, libraries, return services, leagues, clubs, and also a hospital. Through this project, we aim to connect with communities where our collections originate and also share in a two-way knowledge exchange. So you can see here that we have a selection of the tools produced by Jury on display, alongside a real stela from our collection, but this one's a bit later. So it belongs to a man named Wasnefer, a woman named Wasnefer from the later Ptolemaic period. For insurance reasons, we needed to have a different stela other than Ahmose for travelling purposes and a range of other reasons. And we also run making activities around stelae production. So you can make your own paintbrush like the ancient Egyptians, as pictured in the bottom right here, to decorate your own stela using pigments just like those used in ancient Egypt. And luckily, in the case of Bunnings, we could also do some practice carving. So we brought out some of the other replica tools made by Jury and did some carving demonstrations and allowing children and their parents to also participate too onto real Chau limestone blocks. So to date, we've run around 10 pop-ups on this particular theme. We also run other themes as well, reaching more than 1,000 people. So this picture here is from a club in Parramatta in Western Sydney, where there's a large migrant and Arabic-speaking community. And on the right here is in Bankstown Central Shopping Centre. We've also been running activities in hieroglyphs, so learning how to write your name and how to read hieroglyphs, run by Pauline Stanton. And you can see this here at Lidcombe Shopping Centre on the right, and on the left in Auburn Community Centre, who run special programs for recently arrived migrants and also refugees. So it's a really humbling experience to be able to connect with, many diverse audiences, from tradespeople, so pictured here on the left, including carpenters and bricklayers who really connect with us through seeing the tools, many of which are still used by carpenters and tradespeople today. And people then like to share their own experiences working with tools as well. To migrant communities, including Egyptian descent communities in Australia, and to see them engage with their dispersed heritage. Finally, through all of this research, and I'll just emphasize that this is just a mock-up of the front cover, it's not the final design, but we are working right now on a new edited volume in preparation titled Egyptian Stelae in the Chau Museum, Sydney, Their History, Production and Usage in Context. This work is being published by Ben Davies of Abercrombie Press, and it's being edited by myself, along with some Egyptologists from Macquarie University and also Sydney University, Pauline Stanton, Camilla DeBice Dyson, and Eve Gerry. The book includes a complete catalogue of the museum's collection of 20 stelae, in addition to chapters covering the non-invasive characterisation of stelae as an aid to provenance, so that deals with the XRF and qualitative colour analysis by Trevor and Damien. Jeff Killen, Martin and Yuri have written a chapter on tool identification, manufacture and their usage in the production of Egyptian stelae and other stone objects. And Pauline and I are working on a chapter around the use of grids, guidelines and freehand on stelae. There are also chapters around the use and reuse of stelae, pigments and painting techniques, names and handwriting, and of course this experimental work. So it's a really holistic approach to studying and thinking about ancient Egyptian stelae, which has not really been published in this way before. So on that note, I'd just like to acknowledge the many people who have been involved in supporting and making this research possible. As you can see, there are many people on the screen. This is not a project you can do alone. And I welcome any questions you have. So thank you very much for your time.